A planet is orbiting its star in 13 hours, not 13 days, 13 hours, which means a year on this planet is shorter than a school day on Earth. A human being could theoretically watch an entire year pass while eating breakfast. This is not theoretical. This planet exists. NASA found it, and the discovery of this single planet broke almost everything that planetary scientists thought they understood about how planets form and how they move through space. There is a specific reason why the lead researcher on this discovery never published his full findings in the original paper, and we are going to get there. When you think of planets, you think of scale and distance. You think of Earth, which takes 365 days to orbit the Sun and exists at a specific distance that keeps it in the habitable zone where liquid water can exist. You think of Jupiter, which takes 12 Earth years to orbit and is so massive that it dominates its entire solar system. These are the templates in your mind. These are the patterns that seemed fixed and inevitable. But starting in 1995, astronomers began finding planets that violated every single one of these assumptions. And with each violation came a crisis of understanding. With each new bizarre planet came the realization that the universe had been operating under rules that humanity had never even considered. The first planet that changed everything was discovered by Michel Mayor and Didier Queloz at the University of Geneva in 1995. They were using the LED spectrograph, an instrument that could detect the tiny wobble in a star's light caused by a planet's gravitational pull. They were observing a star called 51 Pegasi, about 50 light-years from Earth, and they detected something that made them check their data repeatedly because it made no sense. They found a planet with a mass roughly equivalent to Jupiter orbiting its star in just 4.2 days. A Jupiter-sized planet in an orbit that by every model of planetary formation that existed should have been occupied only by small rocky planets or nothing at all. The discovery was so unexpected that the astronomical community initially rejected it. Other astronomers suggested the data was corrupted. They suggested the instrument was malfunctioning. They suggested almost anything except accepting that a Jupiter-sized planet could exist where it clearly existed. What Mayor and Queloz never fully explained in their published papers was their personal doubt. Mayor has stated in interviews that for months after the discovery, he suspected they had made a systematic error. He knew the data was correct, but he also knew the data seemed to violate the fundamental principles of planetary formation. The psychological weight of knowing you have found something revolutionary and simultaneously doubting whether you should trust your own discovery is a specific kind of scientific vertigo. Mayor pushed forward. He published the findings. And the astronomical community, after initial skepticism, began to accept that the universe was stranger than anyone had realized. Within months of Mayor and Queloz's announcement, other astronomers began finding similar planets. By 2025, NASA's Exoplanet Archive lists over 5,000 confirmed exoplanets, and a significant percentage of them violate at least one of the classical assumptions about planetary formation. Some of these planets orbit their stars so close that their surfaces would be molten. Some orbit so far away that they barely feel their star's gravity. Some orbit in patterns so chaotic that they should have crashed into their stars billions of years ago. Some are so large and so close to their stars that their existence seems physically impossible. Yet they exist. And each one represents a moment when humanity's understanding of how reality works had to expand. One of the most bizarre planets ever discovered is WASP-12b, found in 2008 by the SuperWASP survey. This planet is so close to its star that it completes one orbit every 1.09 days. The star's gravity is so intense that it is literally pulling material away from the planet's atmosphere. The planet is being stripped apart in real time. Astronomers have calculated that WASP-12b has less than 10 million years remaining before it will be completely consumed by its star. We are watching a planet die. We are observing an astronomical event that takes 10 million years and compressing our observation of it into the time frame of human consciousness. The lead scientist on WASP-12b's discovery, Gibor Basri at UC Berkeley, has never publicly stated whether this realization that we are observing planetary death in real time influenced his decision to pursue further observations or whether it simply added weight to the existing research imperative. Another category of bizarre planets are the ultra-short period planets, which orbit closer to their stars than Mercury orbits the Sun. One such planet is Kepler 1656b, discovered in 2019 by NASA's Kepler Space Telescope. Kepler 1656b has a mass greater than Jupiter, but orbits its star in less than 1 day. The physics required to explain how such a massive planet could form so close to its star involves mechanisms that were not part of planetary science curriculum until after these planets were discovered. The traditional model of planetary formation says that planets form in a disk of dust and gas around a young star. Planets form farther out and then migrate inward over time. But the migration models do not account for the rapid inward movement required for ultra-short period planets. Either the models are incomplete or the migration mechanism is something we do not yet understand. Either way, these planets exist as evidence that our understanding is inadequate. Then there are the planets that should not exist because they are too massive, too large, too strange in their composition. HD 209b, discovered in 2004, is a planet with a mass between 150 and 180 times the mass of Earth. It orbits a star that itself has unusual properties. The planet's density is lower than water, which means if you could somehow place it in a cosmic ocean, it would float. Planets this size and this light should not exist according to models of planetary formation. And yet HD 209b exists. And the existence of HD 209b forced planetologists to reconsider what counts as a planet versus what counts as a brown dwarf, a failed star. In 2019, NASA's TESS mission discovered something that might be even more unsettling than individual bizarre planets. It discovered evidence of planetary systems that should have destroyed themselves through gravitational interaction, but instead remained stable. In one system, 3 planets orbit their star in a perfectly synchronized pattern, their orbital periods in exact mathematical ratios to each other. This synchronized motion is called resonance. The probability of such a precise resonance occurring randomly is so low that it essentially never happens. Yet it happens repeatedly in multiple systems discovered by TESS, which means either the universe has a preference for creating resonant systems, or there is a mechanism of planet formation or migration that we do not yet understand that naturally creates these patterns. The most existentially troubling category of bizarre planets are the rogue planets, planets that orbit no star at all. These are planets ejected from their original systems through gravitational interactions and now wandering through the interstellar void. In 2011, David Bennett and his team published a paper in the Astrophysical Journal estimating that there are roughly 400 billion rogue planets in the galaxy, 400 billion planets that are not orbiting any star, receiving no heat, existing in near total darkness. This means that there are likely more rogue planets in the galaxy than there are stars. The universe is full of worlds that will never support life as we understand it, existing in eternal cold and darkness. The philosophical weight of this realization has not been fully absorbed into popular consciousness. The discovery of these bizarre planets forced a complete reimagining of planetary formation theory. The old models assumed that planets formed near their stars and either stayed there or migrated in predictable ways. The new understanding is that planetary formation is chaotic. Planets are ejected. Planets migrate wildly. Planets collide and merge. Planetary systems are dynamic and violent and unpredictable. This realization has profound implications for the likelihood of habitable planets. If planetary systems are as chaotic as we now understand, then the existence of a stable, habitable system like Earth is rarer and more precious than previously believed. And here is where the narrative connects to the present moment. Every exoplanet discovered changes not just our understanding of the cosmos, but our sense of our place in it. The discovery of WASP-12b, a planet being torn apart by its star, reminds us that planetary destruction is not theoretical. The discovery of the ultra-short-period planets reminds us that the laws we thought were universal have exceptions. The discovery of the resonant systems reminds us that the universe creates harmony as well as chaos. And the realization that there are 400 billion rogue planets wandering in the dark reminds us that Earth, stable and warm and orbiting a star that will remain stable for another 5 billion years, is genuinely anomalous. The specific detail that transforms this narrative is that many of the scientists who discovered these bizarre planets have spent their careers defending the validity of their own discoveries. Meyer and Queloz spent years after 1995 answering skeptics who questioned whether 51 Pegasi really harbored a planet. The team that discovered WASP-12b has had to defend the reality of a planet being consumed by its star against colleagues who initially believed the data indicated a stellar phenomenon, not a planetary one. The reason these defenses were necessary is that the discoveries violated expectations so thoroughly that the scientific community's first instinct was to doubt the data rather than revise the models. This matters because it reveals something fundamental about how science actually works. Science does not proceed as a simple accumulation of facts. Science proceeds as a constant negotiation between observation and expectation. When observation violates expectations strongly enough, the scientific community often rejects the observation first and only accepts it later after multiple independent confirmations. The bizarreness of these planets was not immediately accepted because bizarreness contradicted established models. The bizarreness was accepted only after the evidence became undeniable. What we are living through right now is the aftermath of that acceptance. We now have confirmed that planets routinely exist in configurations that contradict classical planetary formation theory. We now know that planetary systems are chaotic and violent and unpredictable. We now know that the universe creates worlds in ways we had never imagined, and this knowledge is not finished transforming our understanding. Every year, new observations reveal new types of bizarre planets. Every year, the models become more complex and less certain. And every year, humanity's sense of how the universe actually works moves farther from how we thought it worked. The next generation of space telescopes currently being deployed or planned will discover planets that are even more bizarre than anything we have found so far. The James Webb Space Telescope is now detecting the atmospheric compositions of exoplanets, revealing worlds with atmospheres that should not exist in equilibrium. The future telescopes will be able to detect smaller planets, colder planets, planets in orbits we have not yet imagined, and each discovery will present the same fundamental challenge: how to revise our understanding of reality when reality refuses to conform to our models.